Hi, Assalamualaikum and hello. Today we're going through to chapter 6 for DBS10012 Engineering Science, which are heat and temperature. Let's go. So what is the definition of temperature and heat? Temperature is a measure of a degree of hotness or coldness of a body, and its unit is in Kelvin, while heat is a thermal energy transferred from one object to another because of different temperature, and its unit is in joule. There are three ways of heat transfer, which are conduction, convection, and radiation. Through conduction, the heat transfer by touch, while convection, the heat transfer to another substance, and radiation, the heat will transfer through electromagnetic wave. Now we're going through to heat capacity. What is heat capacity? Heat capacity is the amount of heat required to raise the temperature of a body 1 degree Celsius or 1 Kelvin. The unit of heat capacity is joule per Celsius or joule per Kelvin. And the heat capacity of an object is calculated in the following ways. C equal Q over delta theta, or C equal to MC. These are an example question regarding to heat capacity. Now we are talking about specific heat capacity. Okay, what is specific heat capacity? Specific heat capacity is the amount of heat required to raise the temperature of 1 kilogram body by 1 degree Celsius or 1 Kelvin. The unit for specific heat capacity is joule kilogram per Kelvin or joule per kilogram Kelvin. The heat capacity of an object is calculated in the following way. C equal to Q over M delta theta, or Q equal to MC delta theta. While delta theta is the changes in temperature. Now this is the examples of specific heat table for certain substances such as ice, aluminium, concrete, glass, iron, until mercury. So different substances have a different specific heat capacity of their own. Now we're going to solving a problems involving specific heat capacity. Let's take a look. Electrical energy from an electric heater. So electrical energy equal to Q over PT, while heat energy is Q over MC theta. So PT is equal to MC theta. How about kinetic energy? The kinetic energy of a moving object is transformed into heat energy when it is brought to rest by frictional force. As we know, kinetic energy is EK equal to half of mv square, while heat energy is equal to Q equal to mc theta. Then we will get half mv square equal to mc theta. And regarding to potential energy of a falling object, as potential energy PE equal to mgh and heat energy equal to Q equal to mc theta, then we will get mgh equal to mc theta. This is an example question regarding to specific heat capacity. Now let's look at latent heat. What is latent heat? Latent heat is an energy absorbed or released by a substance during a change in its physical state without changing its temperature. And the formula is L equal to Q over M. And the unit for latent heat is joule per kilogram. Now, let's take a look. This is an example of a latent heat. An ice has degree of minus 20 degrees Celsius and turn to a hot water of 50 degrees Celsius. So let's take a look how it goes. So ice is minus 20 degrees Celsius, and then it will turn to an ice of 0 degrees Celsius. Lastly, when we boil the water, it will become a hot water with 50 degrees Celsius. That is what we call a latent heat. It changes from minus 20 degree into 50 degrees Celsius. Now, the changes from ice of minus 20 degrees Celsius to ice of 0 degrees Celsius, we call it Q equal to MC theta. Then, from ice of 0 degrees Celsius to ice of still 0 degrees Celsius, we call it as Q equal to ML. Then the changes of the ice when we boil the water to 50 degrees Celsius is called Q equal to MC theta. Again, the changes of degrees Celsius. So how much heat is needed to transform 500 gram of ice at minus 20 degrees Celsius into water at 50 degrees Celsius? So, from the formula, we have a latent ice. Heat latent is 3.33 times to 10 of power 5, and Celsius is 2220. We total up all the total heat changes from ice of minus degrees Celsius into hot water to 50 degrees Celsius, and we get all the total heat. Now, next we are going to talk about thermal equilibrium. This is a very important situation, which thermal equilibrium says that there is no net flow of heat between two objects, and temperature of two objects are equal, which are a heat release is equal to the heat absorbed, which are Q1 equal to Q2, and M1C1 theta equal to M2C2 theta. So, the result will be the final temperature of a mixture will achieve the thermal equilibrium that causes the temperature of water in the beaker A is same to the temperature of a beaker B. This is the sums of the examples question that you guys can do. Okay, that's all for chapter 6 all the best, guys. If you are going to achieve excellence in big things, you develop the habit in little matters. Excellence is not an exception, it is a prevailing attitude. That's all. Thank you. Goodbye.